All right, 8-4, day 2, example 1. Just doing examples, they get a little bit more involved today, so you'll get good at algebra. And we're going to throw some trig at you. So we'll start out. Sine of xy equals 2x. Looks harmless enough. Here we go. Derivative. Trig function first, so derivative of sine is cosine. Keep the angle the same. Timesing by the derivative of the inside. Now remember, that's a product rule in there. So that's a u times a v, which means there's going to be two parts to the derivative, which means you have to have it in parentheses because this cosine has to get multiplied by the whole angle's derivative, which has two parts. So here we go. Derivative of x is 1 times y plus, keep the x, multiplying by the derivative of the y, but remember the y prime. And then that equals derivative of 2x is 2. So we got to solve for y prime. There's only one term, but it's trapped in the brackets, so we have to distribute to get that out. So we will have, I'm going to bring the y to the front of this term. Y times the cosine of xy plus, I have an x, y prime, that's going to come to the front, times the cosine of xy equals 2. Okay, now we isolate the y prime terms. There's only one of them, so I'm going to leave this one here. I'm going to subtract this one to the other side. So we will be subtracting that over. So we have x, y prime, cosine of xy equals 2, subtract y cosine xy. Solving for y prime, we just got to divide by these two things. I could have pulled that y prime term in front of this whole thing, but we're just going to divide by x cosine of xy. So there it is. Well, that fraction there, I'm not going to take the time to rewrite it again. Okay, on to number 2. We have cosine of x minus y equals y times cosine of x. Okay, over here it's just a trig function, so we're starting with the derivative of cosine, that's negative sine of the angle, multiplying by the derivative of the angle, but the angle has two parts, so we need those brackets again. So it's not a product rule because there's a subtraction, so derivative of x is 1 minus derivative of y is also 1, but then that's multiplied by a y prime. Over here, I see y times cosine of x. Hopefully, you see that as a product rule. So, starting with the derivative of y, that's going to be 1 y prime, timesing by cosine of x, plus, keep the y, derivative of cosine is a negative sine x. Now, got to get y prime terms to one side. But this y prime is trapped in the brackets, so before we can do that, we have to distribute. So it's negative sine of xy times 1. And then it's going to be a negative sine times this negative y prime. That's going to be plus y prime times the sine of x minus y. Just brought the y prime to the front of it. And not touching anything over here. But I am going to float this negative here to the middle and have subtract y sine of x Okay, I got two y primes. They're on opposite sides. I got to get them together. I think I will bring this y prime over here and this non-y prime to the right-hand side. So I will add sine of x minus y then I will be subtracting y prime cosine of x so writing this out, we'll have y prime sine of x minus y prime cosine of x. Just writing those two down. Over here we've got, I'll write this one first, sine of x plus y, and I still have this minus y sine of x. 2 steps to go. We're going to basket factor out the y prime, leaving sine of x minus y minus cosine x equals, I'm just going to, I'll write it out. And the last step is to divide by this quantity. So we're going to divide and divide both sides by this. So sine x minus y. I'm just going to ditto that just to save some writing. And there it is. Y prime equals that ugliness. And we're good there. Next one. Number 3. This one's a doozy. xy equals tangent of xy. Now, I'm going to tell you what the answer is. So we're not done until we get y prime to equal negative y over x. That simple. All this is going to turn into just a simple fraction. So here we go. On the left, hopefully you see product rule. So derivative of x is 1 timesing by y plus, keep the x, derivative of y is 1 but times y prime. Now we're at tangent's derivative, that's secant squared, keep the angle, and then multiply by the derivative of the angle. That's a product rule. That has 2 parts to it. But I already did this derivative over here. So I'm just going to copy it. It's y plus xy prime. I'm not going to think about it again because it's exactly the same. Oh, y prime, make that more distinctive there. All right, I've got a y prime here and here. This one's trapped. You have to distribute to release it. So y plus xy prime. We will have, we're going to bring the y to the front of this first one. So it's y secant squared xy plus we will have x y prime secant squared xy. All right, so I'll bring this y prime over with this one. Take this non-y prime term over here. So let's subtract the xy prime. And then we'll subtract this y secant squared xy. So over here, I'll start with the y. Subtract the y secant squared xy. That's all that's on the left. Those are gone. Over here, I'll have this term, xy prime secant squared xy minus this xy prime. Okay. Lots of writing. So over here we got the two y prime terms. So we'll factor out the y prime. X secant squared xy minus x. And we have y minus y secant squared xy. Last step is to divide. Well, what appears to be the last step. So we will have an x minus, x secant squared xy minus x. I just dittoed it there, save some writing. Okay, I'm done. Maybe. So this y prime equals this ugly fraction. I said I was supposed to get negative y over x. So there's a little bit of work we have to do. What can I do here? If I look at the top, I see a y in both baskets here. I'm going to factor out a y from the top. In the bottom, I see two x's in the baskets. I'm going to factor there. So factoring out a y, that will leave 1 minus secant squared. Down here, I can factor out an x. That will leave secant squared minus 1. Oh, look at how close these are. My secant squared is positive here, it's negative here. My 1 is negative, my 1 is positive. So they're exact opposites of each other. So what we can do is factor a negative 1 out of either the top or the bottom. It doesn't matter. I'm going to take it out of the top one. So if I factor out a negative 1, that makes this negative 1, this positive. Now these two terms are exactly the same, and I can cancel them. And I've got y prime equals a negative y over x. Crazy. All right, and our last one isn't as bad. It's our easiest one. We're doing something two ways. It's going to take longer to write the directions down than it is to actually do it. So number 4. We want to prove that the derivative of a power rule with rational exponents so we're going to be doing power rule with rational exponents is the same as the derivative of implicit differentiation with integer exponents. Okay, so we'll be doing power rule with rational exponents and implicit differentiation with integer exponents. So here we go. We'll start with power rule with rational exponents. Y equals x to the 7/4. So we're going to do a power rule. And this is a rational. Remember, rational is anything that can be written as a fraction. So y prime equals power rule 7/4. X subtracting 1, which is subtracting 4 over 4, leaves 3/4. Easy. Now, the other way. We got to start with the same equation, but I have to start with integer exponents. So in order to get this, I got to do something to both sides of this equation to get rid of this fraction. And remember, when you have power to a power, you multiply. So if I put this to the 4th power, when I multiply, the 4's are going to cancel and leave me with x to the 7th, which is an integer. So I'm going to put this side to the 4th power, which means I got to put the left side to the 4th power. So my new starting equation is y to the 4th equals x to the 7th. So I've got the integer exponents, and now because I've got y to the 4th, I have to do it with implicit differentiation. So here we go. 4y cubed times y prime equals 7x to the 6th. Solving for y prime, I got to divide by 4y cubed. So y prime equals 7x to the 6th over 4y cubed. Looking back, ooh, not the same. Well, we're not done. The reason they don't look the same, this is what I did yesterday, is because this one is in terms of x and y, and this one's only in terms of x. So I want to get this one just in terms of x. So I need to get rid of the y, so I've got to do a substitution. Well, right here we had y is equivalent to x to the 7/4. So that's a direct substitution I can make. In place of y, we're going to put x to the 7/4. So now we get 7x to the 6th over 4. Y is x to the 7/4. I got to cube that to the 3rd power. So now, showing that they're supposed to come out the same, we'll take care of this. We multiply here. 7x to the 6th over 4x to the, this will be multiplying, I'll have 21/4. And now to combine these, remember when you're dividing, you subtract exponents. So this will be 7x to the 6th, subtract 21/4 over 4. So this will become, if I put that over 1, that'll be 4. See, 24 over 4. 24 minus 21. There it is. 24 is 3/4 over 4. There's my equivalent derivatives. So that's it. Just be careful today.